Oh yes, of course, today it's a beautiful day, sunshine, but for a couple of weeks there's almost no sun, so I faced a problem. My charge controller couldn't charge almost nothing into my deep cycle battery. As you may see, I put it in a box to save a couple of temperature, a couple of degrees. That's my new deep cycle battery, 100 amps, 12 volts. So I had to find out a way to keep it charged, or at least to avoid 50% DOD. So finally I realized that a kind of maintainer, if I may say that, should do the job. So here we are. It's a very simple circuit with LM358. I found out this is the most practical one, and it's working really nice. And you may see up there I have a relay, and the relay it's going to here and connecting a Toshiba adapter, a Toshiba 14 volts adapter, which I place it inside the box. So that's a Toshiba laptop adapter. In fact, it's like 14 volt with 4 amps. I put it inside the box in purpose because when it's working it's getting a little bit hot, and it's keeping the temperature high, because inside here, well, I may say it's not so hot. I have like 5 degrees, 6 degrees Celsius. So guys, this maintainer or float charger, I don't know how to call it, it's working very simple. When the battery goes down to, let's say, 12.1, 12.2 volts, then the relay is on and the charger is on, and it goes up to 12.6, 12.7. It takes maybe 3, 4, maybe 5 minutes to do that, and then it stops and goes back down to 12.1. So somehow it's the voltage is jumping up and down 0.5, 0.6 volts, but that's more than enough to keep the battery charged to a certain voltage, like let's say jumping from 12.1 to 12.6. It's on the green zone, I may say. Well, a little bit later I'll show you how to do this. It's a very simple circuit, so you can try it, and you can make it on a piece of board like I have. It's nothing special. It's just soldered behind, and like I said, it's working surprisingly good. It's working very well, and instead of wasting money buying new batteries after too much discharge and sulfatation, and you know, all that kind of trouble you may have when the battery is more than 50% DOD, I prefer to waste a couple of bucks, you know, and to put some energy from the mains inside the battery. Okay, so that's my main charge controller. It's an AP Ever or AP ever tracer 4210. It's an MPPT solar charge controller, 40 amps. I think it's like 90 volts in, but for now I put 300 watts panels in parallel. I have two panels of 150 watts. You may see the battery already have 1.3 13.2 sorry volts. In a couple of hours it's getting a lot of energy. Like I told you, it was 2 weeks of cloudy and a lot of snow and stuff, like, you know, winter stuffs. Okay, this little thing here, it's not exactly charging the battery in a proper way, because there is no boost or flooded or you know, all those three kind of charging the battery, or three steps of charging a battery. This one is just maintaining somehow the voltage in between a certain limit. So that's why it's nice, because it's never going under 12.1 volts. And as you may see there are two potentiometers, the blue one and the other one down there, so I can adjust the levels, you know, the down level and the upper limit, the down limit and the upper limit, and this is really helpful. I'll show you later the schematics and how some ideas how you can put all these things together. And also there is a very important trick. Somehow this little circuit, it's supplied by 12 volts from the battery directly, and I observed if I put the adapter and 12 volts in, if I put these things together, I mean theoretically they are on the same line, so somehow they are connected together from the schematic, but that's the way the schematic it shows. But it's not working like that, because then you'll have a kind of how can I call it, kind of feedback signal, and that makes the IC crazy, and the relay it's buzzing like a bell or something. Anyway, it's not working like that. I think there should be a difference between the 12 volts from the charger to the battery and the other one going to the electronics. So that's why I connected the electronics over here. That's the load, the out of the charger, with a longer wire. So the wire it's like maybe 1 meter long, and the other one inside the battery is very short as possible. So that makes a kind of resistance difference in between the electronics and the charger, and it's good enough to cut off the feedback. So there is no crazy reaction. It's a very clear on and off switch. And also I may say, I tried many operational ICs. It's looking like LM358 or LM328. This kind of circuits, they are working properly. They are working very well. The others are always making all kind of hysteresis problems, some feedback problems, and any kind of other stuffs. I already destroyed a couple of relays, and they are not so cheap. They are 12 volts relay, and I found out that 358 it's working very nice. So the switching between on and off, it's very nice and clear. There is no hysteresis and no feedback and no any other crazy phenomena. Okay, next still have the schematics, and I'll show you how to put the things together. Okay, here we are on the roof, and this is one of my 150 watts panel, and up there I have another 150 watts, and for now I put them in parallel because there is a lot of snow, and I found that if I'm using them in series, they are blocking each other. So now I know for sure one of them it's working properly. Okay, so we are back in now. Okay, that's my piano. Got nothing to do with solars, and that's my favorite laptop. I call it Frankzilla because it was destroyed and threw it away by a friend of mine. I put it together in a special way, as you may see. It's looking really crazy, but it's working. That doesn't matter. All right, so for this little circuit, I used something like this, or like this. It's the same. So all you have to do is to plant the pieces there on the other side, of course, and make all the connection by the schematic, by wire. Here, it's a very simple way to do it, very basic, and it's working very well. Okay, this was one of my first attempt. It's looking really ugly, but I've been trying and testing a lot of stuffs here. That's one of the relays, one of the destroyed relays, and testing time. I really recommend you to have this kind of socket for, I don't know if you can see it, for the IC. It's much better because then if something wrong happens, then you can take it. You can take the IC out and replace it with a new one. And here's the schematic. You know, it's a very simple one. At the end of the video, you're gonna have a couple of shootings with all the pieces together. So that's the schematic here. It's very simple. And that's the way to connect the things. Okay, so that's the connection schematic. The connection between the panel and charger and the power supply and the auxiliary charger and the battery and all the other things. With blue we have the panel, with yellow that's the MPPT charger, the battery it's on the right there, you see it. With orange it's the maintainer, I may call it maintainer, I don't know how to call it anyway, but I think maintainer should be a good name for it. And with pink or purple, it's the power supply, you just saw it, the 14 volts power supply. You may see, like I told you before, the 12 volts or 14 volts in fact from the power supply, somehow physically it's connected to the 14 volts in or 12 volts in of the maintainer. And you see, the maintainer it's always connected to the load. Or you can try to connect it to the battery all the time, because it's not taking too much power. It's like 15 milliamps when it's off, when it's standby, and maybe around 60 milliamps when the relay is on. So it's not a big charge for a big battery. So the maintainer, it's always on the battery, and like I told you, the wires should have a absolutely different length. The ones from the power supply to the battery as short as possible, and the other ones longer than 1 meter. So that's the way you can avoid the feedback, and that's how the circuit is doing a very clear on and off switch. Okay, it's nothing more to say about this. If you have any question, just ask about. I'll do the best to help you. And like I told you, it's a really nice circuit, because it keeps your deep cycle battery somehow in a state of charge, and it's also providing some power to the load. You know, I'm using this for a surviving camera, surveillance camera, and I have 3 cameras and 1 router and a couple of lights outside. So the total power, it's around maybe 20 watts, 22 watts. And because weeks without sunshine, there is no more power in the battery, and somehow this circuit is supplying, also maintaining the battery in a proper charging, and also it's supplying a part of the power needs for the load. At the end of the video, you'll have some shootings with the schematics, and like I said, if you need any help, if you have any question, don't hesitate to write them down, and I'll do the best to help you. Okay, let's talk a little bit about the schematic. As you may see, on the left we have PS, that's the power supply, 14 volts, around 4 amps. And next it's a condenser. We have a 1000 microfarad condenser, electrolytic condenser, and after we have a Zener diode and 1 kilo resistance. Well, this Zener diode gives you a very straight voltage. You can use one between, let's say, 5.1 to 5.7 volts. And the next one, it's our IC LM358. It's a very common operational circuit. Later, from pin 1, we have through 1 kilo resistor an LED, a green one or a red one, depends on you. I put a green one. And afterwards, from pin 1, then we have a resistor, a 33 kilos, goes to an NPN transistor. It can be any common NPN transistor, as long as it's supporting the current necessary for the relay. I'm using BD135, a very old transistor found in my shack. Sometimes the 33 kilo resistor to the base of the transistor, maybe it needs a little bit of tweaking, maybe it's too big, then it goes down to 10 kilo, but depends on the transistor. I found the 33 kilo working very well. Afterwards, same pin 1, out from the pin 1, we go to another transistor through a 1 kilo resistor. This T2, it's a very common NPN transistor. You can use any kind of NPN transistor like BC548 or any kind, because there is no power on it. It's just doing a kind of buffer in between the things. From the collector we go to 500 kilo potentiometer, and then it goes to a 50 kilo potentiometer. Okay, this 500 kilo you can adjust the upper limit and also the length, if I may say, the interval in between the lower limit and the upper limit of charging. So I found like maybe around 60-70 kilo, then you go to 12.7, 12.8, but that depends. So the 50 kilo resistor potentiometer, in fact, it's adjusting the low limit. So you have to turn it up and down until the green LED is lighting. For me, it was very useful to connect it to a variable power supply, so I could adjust, let's say, from 12 volts, then I'm going up to maybe 13 volts, and in between these things, then I can adjust the on limit from the 50 kilo potentiometer, and that's it. Now about wiring diagram, the wiring schematic. Then don't forget that physically somehow the power supply, the extra power supply, let's call it the helping power supply, it's connected to the battery and to the maintainer in the same time. But like I told you before, it's very, very important that the wiring, the wires from the power supply to the battery should be as short as possible, and the other one going to the maintainer, you may see it like being a kind of testing probe or something, but anyway, those wires should be longer. I've been connecting the maintainer to the load, the output from the solar regular charger, but it's the same if you just connect it to the battery. But like I said before, don't forget to have longer wires. This is very important. If you don't have this, or if you put together, the power supply out with the maintainer in and the battery all together, then you'll have a kind of feedback, and it's gonna be a mess. It's not working like that. I don't know why, but I suppose it's the resistance in between wires and the delay between the relay action and reaction, something like this. Anyway, it's a very interesting phenomenon, and I was really surprised to find the solution by having longer wire to the maintainer. So that's all about, and wish you luck, and like I said before, if you have any question, just write them down and I'll do the best to answer. Thank you.